we are given this diagram. This is B, C, and A. To find the coordinates of B, what are the restrictions given to us? What is so special about this point B? It is satisfied by equation of AC. Point B falls on the line AB. It falls on the line BC at the same time, so simultaneously. If I can solve these two equations simultaneously, I will get an answer. Do I have the equation for AB and BC? Yeah, in part 2, you are told to find the equation of AB and BC. Do you have that equation? Oh, okay. So do you know how to get it now? Do you know how to do part 3 now? If you have the correct equation for AB and BC. Yes, right? So now the problem is, how do we find the equation for AB and BC? Yes? Okay. Next question. Well, for C, we've got 7, -1. We also know that MC is parallel to AB, BC is parallel to AM, and then there's a point D over here, -5, -3. They also gave us information that AM is perpendicular to the bisector of DC. Okay, if you want to find the equation of AB, I require either 2 points or 1 point plus 1 equation, right? Do you have 2 points on AB? Known points. The coordinates of 2 points on AB. Have or don't have? At the moment, have or don't have? Don't have. Well, so we cannot do that approach. But if we have the coordinates of 1 point plus the gradient, I can still find the equation, right? Can you find the gradient of AB? How? It is the gradient of DC because they are parallel. Yes, you are right. You can find a gradient. Can you find one set of coordinates on AB? Which one? A. How to find the coordinates of A? Oh, you already have it in part 1, right? Oh, okay, so you have the coordinates of A already. You have the gradient. Then you can find equation of AB is y equals to whatever. You can do that yourself, right? Now that that is done, let's talk about the equation of BC. Do you have 2 coordinates on BC? 2 known coordinates on BC. Have or don't have? Don't have. You only have C, right? You don't have B. You don't have anything else. So cannot. But do you have the gradient? How? The gradient of BC is the gradient of AM. Do you have the gradient of AM? You can find the gradient of AM, right? Using this coordinate, and do you have M? Yeah. Using these 2 coordinates, we can find a gradient. That is one way. The other way is gradient BC times gradient DC equals to -1. This one you already know. So with 1 point C over here given and the gradient, you can find the equation. Alright? And with that, we can solve that simultaneously and find the equation, the coordinates of B. Area of trapezium. Anybody needs me to go through? Okay. The other question that I gave was 9, yes. Anybody needs help for 9? Okay, let's start with part 1. Any problem? Part 1? No problem. Part 2? No problem. Part 3. Okay, so that's the one you all need. Let me see the question. If there is only one way for me to draw it out, I'm sure I can get the answer, and it should be the same for you also. There's a right angle triangle, ABC 90 degrees. Okay, I know that eventually they are going to be talking about product of gradients. So this is B, 2, 7, Oh no, wrong drawing. Okay, this one right angle. P, Q. Yeah. Horrible. I have just drawn the diagram. Without looking at part 1, 2, 3, 4, I see what I can find out first. Given two coordinates over here, B and A, I can find the gradient of this line, right? AB, I can find the gradient. I can find the equation. If I can find the equation, I can find I know the y-intercept, right? Y equals mx plus c. Therefore, I know the coordinates for P. That's the y-intercept. I also know the gradient of BC, because the product of gradients of two perpendicular lines will be -1. Since I know the gradient of BC and I have one coordinate, point B, I can find the equation of BC. So these are the things that I can already get. I can get equation of, I have equation of AB, means I have the gradient AB, I have the y-intercept AB, which is actually point P. Then I have also the gradient of BC, meaning I have the gradient equation of BC. If I have the equation of BC, I can find the x-intercept, meaning point Q. So these are all the things that I can obtain. Coordinates of Q, or coordinates of P, coordinates of... No, I don't have coordinates of C so far. Okay? Then they say that BC equals to 2AB. BC, the length over here, is 2 times of AB. So if I say that this is BC equals to 2AB. Find the coordinates of C. Based on this, are you able to tell me the length of AB first? Yeah. You can, right? Our length of line segment. Then, are you able to find the length of BC? Yeah. Because it's simply double, right? Then, point C over here, do you know any of the x or y coordinates? Anything at all? Don't have, okay? So let us call it x and y, okay? That is we set that to be the coordinates of x and y. Next thing, we are going to equate whatever information we have. First, BC is equals to 2AB. So the length of BC must be equals to square root of y minus 7 square plus x minus 2 square. Agree with me? Is this the equation for the line segment? Okay. And we know that this is supposed to be 2 times of the length of AB. Then the length of AB is simply square root of 6 square plus 9 square. Am I right? 6 square, 9 square, yes. What do you think I should do to both sides? Square. Okay. Y minus 7 square plus x minus 2 square equals to, can you help me complete it? 2 square. Okay, so that's 4. Don't forget your laws of indices. And inside the bracket, what do I have? 36 plus 81. How much is that? 81. Okay, 117. How many unknowns are there in this equation? Then can solve not? Can solve? Cannot. But what other information do we have? Y equals to? What is the equation for this line, this green line? For this line, equation y equals to, did I ask you to find earlier on? Part 1, equation of BC, what's the answer? Negative? Plus 25 over 3. So these are the limitations to our point C. Point C must lie on this equation. It also must satisfy this equation at the same time. What do you think I'm trying to tell you? Simultaneous equation. This is equation number 1. This is equation number 2. Solve them simultaneously. You will find a value of x and a corresponding value of y that satisfies equation number 1 and equation number 2 at the same time. And it must be point C. Get it? Understand the approach? Any questions? Give me a center. Give me a point. I set it as the center of my circle. 2, 3. Okay, so the center of circle, center is 2, 3. So my circle equation will look like this. X minus 2 square plus y minus 3 square equals to, what do you want the radius to be? 17. I heard 17. 17 square. This is it lah. Okay, let us use decimals to help us verify. Okay, center 2, 3 and radius equals to 17. Okay, so our equation was x minus 2, y minus 3. X minus 2 square plus y minus 3 square equals to 17 square. You get a circle. Okay, and the center will be 2 and 3. 2, 3. Okay, I don't do somewhere here. It is recording. Okay. So this is our center. The radius, if you were to count from here to the end, it will be 17 units. Okay, this is the formula, the equation for a circle. That will be found in your A Maths chapter 6, right after this. But I thought that question is quite a neat introduction. What BD produce means? So this is a term that will be used for your mid-year. No mid-year. It will be used for your CA. Your next test. It will be used for your end of year, so on and so forth. So everybody look at the screen now. BD produced looks like this. You draw a line from B to D. That's BD, right? Produce, you continue. So BD produced looks like this. A point X lies on somewhere on this red line. Somewhere, I don't know where. X is somewhere. But there is a condition. Area of CBD is half area of CDX. Let's find where CBD is. CBD over here. This area is apparently half of the area of CDX. Okay, let me draw CDX. CDX. Do you think which area is bigger, CBD or CDX? CDX is bigger by, okay, it's double the area, isn't it? So I need to draw a big triangle lah. Okay, this is just a rough sketch only. Now, the area over here is supposed to be 1:2, right? What topic was this? E-Maths or A-Maths? It was E-Maths on similarity, right? But are they similar triangles? No, they are not. But what do they have in common? Same height. This is the height. Okay? So if they have the same height, the ratio of area must be the ratio of base. If they have the same height, ratio of area must be ratio of base. So what is the ratio of base? This one, if this is 1 unit, then this must be 2 units, right? So double the length lah. Okay? Do you know how to proceed on from here already? One more time. I draw the circle until very big already. Okay. So we were saying that here I have the red line divided into 3 parts. 3 equal parts. I want to find the coordinates of x. There are many ways to do it. One way is to consider midpoint. This point over here is the midpoint of B. Let me call this point Z. This point over here is the midpoint of BZ. Alright? And midpoint is very easy to calculate, and it is very easy for us to work backwards. If I have the coordinates of point B and this coordinate, I can very easily find the coordinates of Z. Am I right? Just work backwards. So I know that I have the coordinates of Z. No problem. Then, in order to find the coordinates of x, isn't point Z the midpoint again of dx? Over here, point Z is the midpoint of dx. I know point D, I know the point Z. Then I can find x log. Yes? Who is following? Raise your hand. Those following, start work on it now. It's not magic. Then if you are